In earlier video, we have discussed about the classification of solvents, and the solvents are classified as protonic and aprotic solvents, acidic, basic or amphoteric solvents, ionizing and non-ionizing solvents. Now in this video, we are going to discuss the non-aqueous solvents and their importance, and liquid ammonia as one of the important non-aqueous solvent. What are non-aqueous solvents? The solvent other than water that are used for dissolving substances and carrying out chemical reactions are called non-aqueous solvents. And non-aqueous solvents can be organic or inorganic. Organic non-aqueous solvents are benzene, acetone, carbon tetrachloride, glacial acetic acid, etc. Whereas inorganic non-aqueous solvents are liquid ammonia, liquid sulfur dioxide, liquid hydrogen sulfide, liquid dinitrogen tetroxide. These are the inorganic non-aqueous solvents. Now, what are the advantages of non-aqueous solvents over the aqueous solvents? Actually, most of the organic acids and bases are soluble in non-aqueous solvents. Similarly, organic acids and bases are easily titrated in non-aqueous solvents. Non-aqueous solvents help to identify two or more acids in the mixture. So these are the important advantages of non-aqueous solvents. In addition to advantages, there are certain disadvantages of non-aqueous solvents also. Non-aqueous solvents are generally expensive, these are volatile, toxic, and therefore they have to be handled carefully. This is one of the important, so these are the advantages, and in addition to these advantages there are some disadvantages. Now we are going to discuss the important non-aqueous solvent, that is ammonia. Now ammonia or liquid ammonia, it is one of the most extensively studied non-aqueous solvent. It is a protonic solvent and it has water-like properties, and because of this it is extensively studied. It is a protonic solvent as well, and it is basic. It is auto-ionizing solvent. Then most important thing is liquid ammonia shows the striking resemblance or similarity with water in its solvent action. You know, water undergoes auto-ionization. For example, water undergoes dissociation and there is a formation of H plus and OH minus ion. Water molecule also accepts proton and there is a formation of hydronium ion. Net reaction is, in two water molecule there is a auto-ionization. One water molecule transfers proton, at the same time other water molecule gains proton. So water acts as an acid as well as base. It undergoes auto-ionization and it forms hydronium ion and hydroxyl ion. And the ionic product of water, Kw, that is the product of concentration of hydronium ion into concentration of OH minus ion, it is 1 into 10 raised to minus 14 at 25 degrees centigrade. Similarly, ammonia also undergoes auto-ionization. So ammonia, when dissociate, it gives H plus and NH2 minus. So there is a formation of proton and amide, NH2 minus. Ammonia molecule can also gain the proton. It donates electron pair to the proton, act as a base, and there is a formation of ammonium ion. and therefore net auto ionization reaction is two liquid ammonia molecules undergoes auto ionization. There is a formation of cation, that is ammonium plus, which is responsible for acidic property of ammonia, and there is a formation of amide NH2 minus, which is responsible for basic property of ammonia. So the Kb value, that is the ionization constant for base, it is the product of concentration of NH4 plus into concentration of NH2 minus. It is 1.9 into 10 raised to minus 33 at minus 50 degrees centigrade. Now here, from these two auto ionization processes, it is clear that the Kb value or dissociation of ammonia, it is very low as compared to the dissociation of water. Its Kb value is 1.9 into 10 raised to minus 33, and the extent of auto ionization of liquid ammonia is much less than that of water. Okay, in terms of Kw and Kb, it is clearly seen that the ionization of ammonia is much less than that of water, and ammonia can therefore conduct electricity only to a feeble extent. The dielectric constant of liquid ammonia is also much smaller, that is 22, than that of water. For water it is 78.5. The lower dielectric constant results in a generally decreased ability of liquid ammonia to dissolve ionic compounds, and therefore liquid ammonia is expected to be poor solvent for the ionic substances. However, viscosity of ammonia as compared to that of water is low, and therefore to some extent it compensates with the low dissociation of ammonia, and therefore to some extent ionic compounds are soluble in ammonia also. So here these are the important comparison between water molecule and ammonia as a solvent. These are the some physical properties of liquid ammonia and water. Boiling point of ammonia is lower than water, freezing point is also lower, density of ammonia is less than water, dielectric constant of ammonia, it is less than water, and therefore specific conductance, it is for ammonia it is less than water, viscosity of ammonia is less than water, dipole moment of ammonia it is 1.47, and that for water it is 1.85, and Troughton constant, it is nearly equal. For ammonia it is 101.2, and for water it is 109. So these are the some physical properties of ammonia. Now about the solubility of liquid ammonia. Now liquid ammonia, it is expected to be poor solvent for ionic substances due to its low dielectric constant. However, many ionic compounds, metals, non-metals, these are freely soluble in ammonia. The ionic compounds such as thiocyanides, perchlorates, nitrates, nitrites, iodides, cyanides are soluble in liquid ammonia, and the order of solubility of various halides in ammonia is: iodides are most soluble in ammonia, then bromides, chlorides, and fluorides are least soluble in liquid ammonia, whereas oxides, hydroxides, carbonates, phosphates, sulfates, and most of the sulfides are insoluble in liquid ammonia. Ammonium salts like ammonium nitrate, ammonium thiocyanide, ammonium acetate, these are soluble ammonium salts in liquid ammonia, whereas ammonium carbonate and ammonium sulfate, these are insoluble in liquid ammonia. Now, solubility of nonmetals in liquid ammonia. The nonmetals like sulfur, phosphorus, iodine are soluble, and these nonmetals react with liquid ammonia. Now, which organic compounds soluble in liquid ammonia? There are variety of organic compounds which are soluble in liquid ammonia. Organic compounds like halogen compounds, alcohols, ketones, esters, simple ethers, phenols and their derivatives. These are soluble in liquid ammonia. Aromatic hydrocarbons like benzene, toluene, etc. Then alkynes, these are slightly soluble in liquid ammonia. These are not freely soluble, whereas alkenes are almost insoluble in liquid ammonia. So this is about the solubility of organic compounds. So not only non-metals, organic compounds and some salts are soluble in liquid ammonia, some metals are also soluble in liquid ammonia, and some metals are insoluble also. So metals like magnesium, zinc, calcium, lanthanum, cerium, manganese, these metals have low solubilities in liquid ammonia. These are not freely soluble, whereas it is well known that most of the alkali metals and alkaline earth metals are highly soluble in liquid ammonia, and there is a formation of metal cations and electrons, and these electrons are solvated or ammoniated with liquid ammonia, and because of this resulting solution has a blue color. The alkali metal solutions in liquid ammonia are blue in color. This is because of solvation of electrons and cations. So the blue color of the metal ion solution and absorption spectra of different metal ion solutions, it is independent of metal involved. It means when potassium is added in liquid ammonia to get its metal ammonia solution, and another sample is there is a sodium added in liquid ammonia to get its solution, both the solutions have blue color and their absorption spectra will be similar, independent of metal involved. And the conductivity of very dilute metal ammonia solution, it is very high and decreases with increasing concentration. Now blue metal ammonia solution, it is paramagnetic, indicating the presence of solvated unpaired electrons and metal ions. These are the solvation reactions. Metal gives cation plus electron. So metal ion, it is solvated with the ammonia. Electron is also solvated with ammonia. So because of this solvated electron, there is a blue color. So metal ion solution is metastable, and on standing for long time or in the presence of catalyst like Fe2O3, it undergoes decomposition and there is an evolution of hydrogen gas. So metal plus ammonia, so this solution, solvated electron plus solvated metal cation solution, when kept for long time or when some catalyst is added, Fe2O3, then there is an evolution of hydrogen, and therefore this solution is a metastable solution. On standing for long time, it undergoes decomposition.